Hey everybody, my name is Vegard Andersen and I am working on flue gas recirculation for the silicon process. I'm going to give you guys a little bit of an introduction to the topic and talk a little bit about what I'm working on. I hope it's going to be interesting for you guys. So flue gas recirculation is basically taking cleaned off gas and returning it back into the furnace hood, and thereby you replace some of the combustion air with off gas instead. This is a known technique from industrial burners and is used for temperature control and NOx emissions. And it's also in some cases used to increase the CO2 concentration in the off gas. The motivation for looking at this for the silicon process is to see if those benefits are achievable for this process as well. So we're looking at the NOx reduction, looking at increasing energy recovery, and we're also looking at the way of increasing CO2 concentration in the off gas to facilitate carbon capture. So here we are inside the furnace hood where the action happens. By introducing flue gas recirculation to this system, you are changing the combustion conditions in here, and you're doing it basically by reducing the access to oxygen. What we're working on is trying to get an overview of how this change affects all the processes going on in here, and also to experimentally quantify the most important ones. Initially, we've done some flow sheet modeling, done it in a HSC sim model, and we looked at how the two main drivers for increasing energy recovery and CO2 concentration affect the process differently. So we've been looking at recirculation of flue gas and also by just reducing the amount of off-gas volume. And both of them are efficient for both increasing energy recovery and CO2 concentration, but to do it a bit differently. We are also working on developing a small-scale experimental setup to look at SiO combustion in different atmospheres. So here is a very simple setup in an induction furnace where we generate the SiO gas and let it combust in different atmosphere. And then we collect the byproducts in a filtration system and look at how different atmospheres affect this process. To get experimental data that is transferable to the industry, we also plan to do a pilot scale experiment. Here we modify a setup so that we can have full recirculation on a one-phase 160 kilowatt furnace. We use real raw materials, and the goal is to have as comparable combustion conditions within this little furnace here as you will have in a actual silicon furnace. The setup allows us to try different degrees of recirculation and different degrees of off-gas volume as well. So this hopefully will be a very good setup to test our different hypotheses. Okay, that was flue gas recirculation. Thank you for the attention, and if you have any questions, you'll find me in the poster session. Thank you.